I welcome you all to the session of engine system and performance, and today we shall discuss about the digital circuits. And you know, in the last few classes we have talked about semiconductor devices, mainly diodes and transistors, and we have seen these two semiconductor devices are very important for the modern electronic system or circuits. And what we could discuss in our previous class is the use of diodes as rectifiers, essentially to convert periodic or sinusoidal signal into the DC signal. And we have also discussed about the transistors, which are very important, and transistors are having a few distinctive advantages, and these transistors are essentially used to amplify the signal or current, and also transistors can be used as switch. And we also have discussed the modes of operation of transistors. So, today we shall briefly discuss about digital circuits. As such, this is itself a subject, but in the context of the engine system we have seen that electronic control unit or engine management system is essentially housed with a few electronic circuits, and to operate or to run engine smoothly, essentially always, not always, rather to operate engine with its optimum condition to reduce emission level, to maximize efficiency, what we need to do? We need to have a very efficient electronic control unit or engine management system. So, what is a digital circuit? Basically, digital circuits are from binary circuits, and binary circuits are the circuits whose output can have only one or two different states, typically 0 and 1, and these two states are indicated by a particular current or voltage. So, you have studied about digital circuit in your basic electronics course in your undergraduate level, and we shall write today a few important points which are essential to know for any system engineer for improvisation of engine control system, and let us write all those points first and then we will discuss. So, as I said that digital circuits are from binary circuits. Digital circuits are from binary circuit. And as I said you that these binary circuits are those circuits, or are the circuits whose output can be only can be only one or two different states. And these two different states are indicated by a particular value of current or voltage. So, if I write here these two states, typically 0 and 1, are indicated. So, basically on and off. So, we shall see are indicated by 0 means off, 1 means on. So, 0 and 1, these two numbers. So, these two states are indicated by a particular voltage or current. So, that is what we know. Even as I said you from your undergraduate basic electronics course, you have studied all this, but now let us write a few points of this particular circuit. So, you know that we have seen in digital electronic circuit, transistors are used as a switch. We have studied in our previous class that transistors can be operated in 3 different regimes, which are cut off, active or linear, and last one is the saturation. So, if the transistors are operated both in cut off and saturation regimes, then transistors can be used as a switch, electronic solid state switch. That is what we have discussed in the previous class, that is on and off. If we write here now that in electronic digital circuit, transistors are used as a switch. If we need to use transistors as a switch, essentially transistors will be operated in cut off and saturation regimes. So, that means from here we can write transistors will be operated cut off and saturation regimes. That is on and off. If it is cut off, off, if it is saturation, on. So, that is switch, it is acting like a switch. As I told you in the previous class that even a small base current, that is base to emitter, current flowing from base to emitter, beyond a threshold value, even if we increase the voltage in this base emitter circuit, that will increase base current, and even if we increase base current beyond a threshold value, the increase in collector current will be very minimal, because this is the resistance will be very high, that is between this collector to emitter, that resistance is very high. So, it is saturated. So, now no further current can be increased. So, it is on, just on. Okay. So, this is saturation regimes. We know that saturation means when transistor is saturation, very low resistance. So, as I said you that a further increase in IB will not increase conduction collector current IC, that is it is saturated. So, cut off. So, when transistor is in cut off regime, certainly you can understand resistance is very high. As I told you that if the voltage that VB, that is base emitter circuit, if the voltage is less than 0.7 volt, it is not possible to break the barrier that will form when p type n type junction will reach at equilibrium. So, the resistance is very high. When transistor is in saturation, you can understand the resistance is low. So, that is why huge current will flow from collector terminal to emitter terminal, and a small even an increase in current base emitter current will not allow to increase collector current significantly. So, that is the saturation. So, that is what we have learned. Now, the question is, in digital circuit or in digital electronic circuit, control input to the transistor switch, because transistor will be acting as a switch. So, the control input to the transistor switch will be capable of run, or the transistor in control input to the transistor should be capable of running the transistor either in off mode or in the saturation mode, that is on mode. It will not allow the transistor to run in the active or linear regime. So, that is very important. So, let me write here in fact that in digital electronic circuit or digital circuit, control input to the transistor switch must be capable of running the transistor either in off mode or in the saturation mode without allowing the transistor to run in the active or linear regime. Okay. So, that is very important. Now, digital circuits, as I had written before, digital circuits are formed from binary circuit. So, digital circuits function by representing various quantities. So, digital circuits which are formed from binary circuits, and binary circuits are the circuits which can only be one or two different states, typically 0 and 1, and these two states are indicated by two particular value of current and voltage or voltage. So, function this digital circuits function by representing various quantities numerically using a binary number system. So, that means digital circuits can operate by representing various quantities numerically. Digital circuit will understand different or various quantities numerically by using binary number. So, whenever we are trying to send some signal to the digital circuit will understand these two numbers, various quantities, maybe signal, maybe any current, whatever it is, any input quantities, the digital circuit will understand, and then it will function by representing quantities numerically using the binary number system. Okay. So, then we have to have binary, we have to understand a bit about the binary number system. So, let me write here in a binary number system. So, I will be writing a few lines about the binary number system. So, binary number system. In a binary number system, though you have studied all these in your undergraduate basic electronics course, in binary number systems all numbers are represented using only all numbers are represented by using only the symbols. Symbols 1, symbols 1 or sorry, I should write not or, and because these two numbers are used, and 0 arranged in a form of a place, position number system. We shall discuss this taking an example. Okay. So, in a binary number system, all numbers represented by using only symbol 1 and 0. So, 2 state, it is called binary 2 state, 0 arranged in a form of a place position number system. In electronic digital circuit, these symbols can be represented in transistor, either in switch off and on, that is cut off and saturation level. So, if I write here again, electronically these symbols can be represented by transistors in either saturation or cut off. Okay. So, that is very important. So, now you can understand that the need of transistor in digital circuit. Few minutes back we said that transistors are used as a switch. So, between just to have on and off mode. So, we can understand that in binary system all numbers are represented using only two symbols, that is 1 and 0, arranged in a form of a place of a position number system, and these symbols can be represented electronically by transistors in either saturation or cut off. So, this is okay. So, that is what we have understood. So, if we go to the next slide, now we shall discuss today about digital system, digital circuit. We will take up an example, but before going to discuss about the digital circuit, let us discuss about the binary system. Let us a few things. So, binary numbers, if we need to discuss about digital circuit, it is instructive to review the binary number system first. So, we will discuss this binary number system briefly. So, binary number. So, now as I said you that binary number system uses 2 digits, right, 0 and 1. Okay. If the binary number system uses 2 digits 0 and 1, it is called 2 base system. So, it is called 2 base, or it is called 2 base system or a base 2 system. Base 2, I should write 2, rather we can write a base 2 system. So, if we erase it, we can write is called a base 2 system. So, if the system uses 2 digits 0 and 1, then it will call base 2 system, right, and the basically binary number uses 2 digit and which is called a base 2 system. Okay. Decimal system, the decimal system 10 digits 0 through 9 and is called a base 10 system. A base 10 system. So, basically what we can see that binary number uses 2 digits 0 and 1 and it is called a base 2 system, and we have seen basic decimal number system that is 0 through 9 and it is called a base 10 system. So, what we can do now, we can take an example to discuss this part. If we go to the next slide, so if we write 1010 base 2, so this is the representation. So, this is number is a base 2 or binary number. This number is a base 2 or binary number, and if we write 1010, this is also a number, but base 10. So, this is base 10, number is a decimal number, means the number is a base 10 or decimal number. So, this indicates number is a base 10 or decimal number. So, let me clarify this part. So, this is base 2. So, this is base 2. Okay. So, this is a base 2 or this number. Now, question is, we will take an example to see how we can write this any numerical number in the form of 0 and 1, that is binary numbers. So, that we will write. So, conversion of decimal to binary with the help of an example. So, as I said you that, say for example, why do we need to do it? So, whenever digital circuit will understand the binary numbers, that is what we have been discussing today. So, essentially digital circuit will understand 0 and 1, that is the transistor will help switch, because transistor will be acting as a switch. So, it will operate in cutoff and saturation regimes. So, 0 and 1. So, any decimal number has to be converted into binary number to allow digital circuit understand. So, let us take an example for the conversion of decimal to binary number. So, take an example. So, conversion from a decimal to binary number. Okay. So, we take decimal to binary with the following example, decimal number to binary number. Okay. So, if we take this example, let us say 50 base 10. So, as I said if we take this example 50 is a number base 10. So, following our previous discussion, this is a number is a base 10 or decimal number. Base 10 is decimal number because it has numbers, if you go to the previous slide, 10 digits 0 through 9. So, to convert it into binary number, let us write like this. So, the part is, if we write 50, so this is a base 2 number. So, divide it 2, then we will be having 25. If we try to write the remainder is 0, then 25 by 2, it is having 12, remainder is 1, then 12 by 2, 6, remainder 0, 6 by 2 equal to 3, remainder 1, and so remainder 0, 3 by 2, that is 1, remainder 1, right. So, that is what we can write. So, we can write. So, now the equivalent form of the binary number should be 50 by 2, we have to base 2 system. So, binary is a base 2 system, base 2 binary number is a base 2 or binary number. So, divide by 2 25, no remainder, 25 by 2, if it is 12 then remainder is 1, 12 by 2 6, remainder is 0, 6 by 2 remainder is 0, and then 3 by 2 remainder is 1. So, essentially if we write this, so remainder, so if we write remainder 0, then 1 0 0 1, and then this is 1 because 2 it is base 2 1. So, this is basically base 2 number because we have used 2 to divide all this. So, first remainder is 0, second remainder is 1, third is 0, fourth is 0, fifth is 1, and then 2, that is 1. So, this is the binary conversion. Now, let us recheck whether really we could represent 50 that base 10, that is a base 10 number, that is decimal number, into binary number. So, this is basically if I take this, so this is 2 power 0 position, this is 2 power 1, 2 power 2, 2 power 3, 2 power 4, and this is 2 power 5, 2 power 5. So, now if we write 2 power 5 means 32 into 1. So, we can write 2 power 5 into 1 plus 2 power 4 into 1 plus 2 power 3 into 0 plus 2 power 2 into 0 plus 2 power 1 into 1 plus 2 power 0 into 0. So, essentially we will be getting 32 plus 16 plus 0 plus 0 plus 2 plus 0. So, that is equal to 50. So, that means using this method we could write a decimal number into a binary number. So, this is the method by which we can really convert a decimal number into binary number, because we need to convert binary number, otherwise digital circuit won't be able to understand the inputs, because it has only it can have only outputs as I said you 0 or 1. Okay. So, this is the method. Now, see, the very important part is this manipulation of all these numbers, that we need to go for multiplication, we need to go for subtraction, we need to go for division, all these things. So, digit, that is bit. So, in digital systems this binary digit or binary bit, these manipulations are done very easily using some logic gates. So, we will briefly discuss about a few logic gates. So, let me write here that digital systems, it can be computer also, perform binary digit, within bracket I am writing bit, manipulations very easily by using 3 logic circuits or gate. We need to manipulate, we need to go for multiplication, we need to go for division, all these things, all these manipulations are done very easily by the logic circuit. So, we shall be discussing all these circuits one by one. The first is logic circuits or gate. So, we shall be discussing about an AND gate. So, as I told you, these 3 gates are, if we gates, first is AND, number 2 is OR, number 3 is NOT or inverter. So, and for all these 3 gates, truth table is used to describe what combination of input, what combination of input will produce a particular output. So, we shall be using this truth table. So, let us discuss these 3 logic gates briefly. So, the first logic gate is AND. So, AND gate, if we write basically symbolically, and so AND gates are like this. So, output is Y, it has 2 inputs, say A and B, and this is AND gate, right. So, the AND gate, what we can see, so it has at least 2 inputs and 1 output, at least two inputs and 1 output. So, if we write the truth table, so basically if we go to the truth table, so A, B and Y. So, the feature of this particular gate is output is high, means 1, because it has only 2 base, base 2 system only 0 and 1. So, output is high when both inputs are high. If either or both inputs are low, output is low, number 1. If either or both inputs either or both inputs are low, output is low. So, that means when if we erase this and if we write the truth table here, so that is A, B, then Y, the output. So, when both inputs are high, so if it is 0, then 0, if it is 1 0 then also 0, if it is 0 1 then also 0, if it is 1 1 then also 1, right. So, that is the output truth table. Either or both inputs are low, that is low means 0, output is low, low means 0. Okay. So, if you know if you go to the OR gate, so then OR gate, if we write the schematic, OR is so this is Y, again if we have 2 input A and B, output is Y, this is OR gate. So, OR gate, it has at least 2 inputs, and 1 output. Okay. So, let me write here a few points about this particular gate. So, output is high. So, output is high, that is 1 when one or both inputs are high, when one or both any of both inputs are high, that is 1, and output is low when both inputs are low. Right. So, if we now write the or construct the truth table, we will be getting like this: A, B inputs and output is Y. So, what we can see from here, if when both inputs are low, that is 0 0 0, 1 0 1, 0 1 1, and if it is 1 and 1, if it is 1 and 1, so basically then also 1. So, output is high when 1 or both inputs are high. So, both inputs are high, so 1 1, that is 1. So, this is the truth table. So, now if we have the NOT gate, that is the last one, NOT. So, symbolically it is shown like this. So, this is A, right. NOT gate, is a logic converter. NOT gate is a logic inverter. So, if it has one input, it has one input and one output, right. So, that we can see it has only one input A and output is Y. Now, if the input is logical 0, so let me write a few points. If the input is logical 1, the output is logical 0. And if the input is logical 0, input is logical 0, the output is logical 1, right. So, this is the NOT gate, and if we construct the truth table, then we have A and Y. So, when A is 1, this is 0, when A is 0, this is 1. So, this is the NOT gate. So, we have discussed about 3 important logic gates. These logic gates are used for the binary number manipulations in digital systems. Now, question is, last part of this lecture should be to the representation of equivalent digital of this binary digital binary system. So, basically we have discussed about OR, AND and NOT, these 3 gates. In fact, there are many other XOR, NAND and also NOR. So, all these gates are very useful in the context of digital circuit configuration that and I am not going to discuss all these. As such, if you need to know more about it, you can consult with any basic electronics book. So, just to give you some ideas, so we need to have equivalent form of any logic gate. Ideally, we should discuss about, or you should know about the equivalent form of all 3 logic gates that we have discussed, but in today's class as such I will discuss only about OR gate and its equivalent form of electronic equivalent form rather. So, electronic equivalent form of all 3 gates are important to know, that is the digital representation, but we shall discuss about only the equivalent electronic form of the OR gate. So, if we write as such, what you know that whenever any signal is received by a sensor, that is analog, and analog is basically continuous, but whenever we are converting analog to digital, ADC is discrete. So, there must be some quantization of noise. So, noise should be eliminated, is not it, because any analog is continuous, but essentially digital is discrete 0 1 or some numbers. So, 0 and 1. So, discrete. So, this there will be some, it is not possible to have equal conversion of this continuous information to the discrete information. So, there must be some quantization of the noise, but noise should be eliminated, that is very important, that we have discussed so many times. Okay. So, let us discuss about discrete OR gates. So, equivalent or electronic equivalent of OR gate, that is what we should discuss. Okay. So, is electronic circuit, equivalent electronic circuit. Okay. Discrete. So, as I told you, analog is always continuous, but OR is discrete, basically we are having 0 and 1. So, this discrete OR gates may be realized by using diodes and transistors. So, that is electronic circuit. Let me write here a few points first. So, discrete OR gates may be realized by using diodes or transistors. We had seen that first switches, this utility, I mean we can use transistor, the use of transistor for logic gates, we can use transistor for logic gates depends on the utility of first switches. Okay. So, first we consider diode based equivalent circuit. The number 1 is diode based equivalent electronic circuit, and later on we will be discussing about transistors. So, as I told you that the use of transistor for logic gates depends on the utility of first switches, okay, rather depends upon their utility. Transistors can be used as logic gates based on or depending on their utility as first switches. So, diode based let us first discuss, and then number we should discuss about transistor based equivalent electronic circuit. We are discussing all these because we need to know essentially signal that will be receiving from different parts of engine is analog signal. That signal should be converted into digital one, that is in the form of 0 and 1. Then this digital circuit will give some input to the again all those parts to adjust so as to operate engine always at its optimum condition. Okay. So, if we write the diode based 2 input diode gate, so first is 2 input diode OR gate. Okay. So, let me draw the circuit, 2 diodes. So, this is D1 and we have another diode D2, right. So, then this is grounded. If it is resistor R L and this is Z. So, if we have X and Y. Okay. So, these are the inputs, okay, and output it Z, right. So, inputs may be either 0 or 5. So, as I told you that a base 2 system uses 0 and 1, 0 and 1. 0 is used to represent 0 volt, 1 is used to indicate 5 or 3.3 volts. So, these two inputs would be 0 volt or 5 volt, and we are having this electronic equivalent circuit. Let us revisit whether we are getting the same truth table or not. Okay. So, in the diode of OR gate, when both inputs are same, so when both inputs are same, say 0 volt, okay, then both diodes are off, then are off and output will be 0. So, if both diodes are off, no current will flow and output will be 0. So, when both diodes are off, no current will flow. So, output is 0, right. So, and there will be no voltage drop. So, no voltage drop when both inputs are 0 volt. Okay. Output will be 0, but when both inputs or either of the inputs such as x and y are equal to 5 volts. So, when both any or either the input such as x and y are equal to 5 volt, 5 volt, then the corresponding diodes, if it is x is 5 volt, then D1 will be in active mode, if y is 5 volt, then D2 will be in active mode, and if both are 5 volt, then both diodes will be in active mode. That is what we can see from the circuit. So, when then corresponding diodes are both are on state. So, voltage across, so either or both diodes are at on state, right, and net voltage across R1 across resistance, that RL, that is what we have, RL will be 5 volt, right. So, output will be 5 volt, that is 1, right, logic state. So, this one is logic state, right, logic 1 state. So, that means we can see if both are 0, it is 0, if any one of them is 5 or other one is 0 or both are 5, then output is 5. So, that is 1. So, that means we could retrieve the truth table that we have discussed few minutes back. Okay. If both of them are 0, inputs are 0, then output is 0. So, 0 0 0, if either of the input is 5 volt or both inputs are 5 volt, then voltage across RL will be 5 and output will be 5 for all these cases, then that is the logic 1 state. So, it is 0 0 then 0, if it is 0 and 1 then also 1, 1 0 is also 1, 1 and 1 is also 1. So, basically we could retrieve the logic state. So, this is the equivalent representation of the electronic equivalent form of the logic gate, and that is the OR gate that we have taken for today's example. So, with this if we would like to summarize, our today's discussion. We have discussed about the digital circuit, we have discussed bit about digital circuits, and then we have discussed about binary number system, we have discussed about 3 important logic gates, and then finally we have discussed about the electronic equivalent of OR logic gate. So, with this I stop here today, and we shall continue our discussion in the next class. Thank you.